Well, hi guys, back to Calculus AB. So today we're going to look at integration by substitution day 2, and we're going to look at some different things that happens along with this integration by substitution. So today is March 20th. Okay, so the first example is the integral of x times the square root of 2x minus 1 dx. So this is a product right here because we're multiplying x times the square root. All right. And what we want to look at and see is what can we let u be? Well, when we have the square root, if you look at this, we have an inside part right here, 2x minus 1. If we let that be u, okay, let's take a look at that. So let me grab my pen. So let's let u equal 2x minus 1. So this will be u, which is the square root of u. It'll become that. And then that'll be u to the 1/2 power because we can use exponents to rewrite the square root. Okay, now the next thing we can do is what would du be? So if you take the derivative of u with respect to x, okay, the du will become 2, and this the derivative of minus 1 will just be 0. So this is just 2 dx. So we don't pick up this x necessarily, right? Okay, so what we can do with that is we can solve u equals 2x minus 1 for x, and then we'll be able to rewrite that in terms of u. So I'm going to add 1 to both sides, so that'd be u plus 1 is equal to 2x. And then I'm going to multiply both sides by 1/2, or you could divide both sides by 2. This would be u plus 1 over 2 is equal to x. It would be better for this problem if you rewrite this as 1/2 times u plus 1 is equal to x. So this x right here becomes this 1/2 times u plus 1. And let's take a look and see what happens if you do that. It's going to make the problem easier. Because remember I talked the other day about it does make the problem easier when you do this u substitution. So this is equivalent to the integral. And then we're going to put in our x. Our x is this 1/2 times u plus 1. And then, okay, so that's that in essence is the x we have right here, right? It's this x right here. And then we have multiplying by the square root of u. And then times, we have the dx, right? Okay, so we need this to become du. Well, what was du? Well, it was 2 times dx. So we actually need a 2 with this dx. Well, I can fix that by multiplying by 2 and also multiplying by 1/2 at the same time. So I'm going to rewrite this dx in this way. So this is going to become the integral of 1/2 times u plus 1 times the square root of u times 1/2 times 2, because 1/2 times 2 is 1, times dx. And then this 2 dx is going to become my du. Everybody all right with that? I wish I could hear you guys' answers. I miss you guys. All right. So here, what we can do is pull out this 1/2 and this 1/2 and pull it out as 1/4. So 1/4 times the integral. Okay, so this came out and this came out. We have u plus 1. This u right here, the square root of u, I'm going to rewrite as u to the 1/2 power. And then this is my du. Okay? Now, how do you integrate something like this? Because it's supposed to get simpler, right? Well, it is. What we need to first do is distribute this u to the 1/2. So this is equivalent to 1/4 times the integral of u times u to the 1/2. Well, this is u to the 2/2, so when we multiply this, we would add the exponents, and that becomes u to the 3/2 plus u to the 1/2, and then our du. So we're going to add 1 to our exponent and divide by it, okay? So we still have this 1/4 on the outside. And remember, that 1/4 came from this 1/2 and this 1/2 being pulled out. And we'd have 1/2 times 1/2. That's how I got this 1/4 right here. And it's going to carry along down the problem with us. Okay, so then we have 1/4 times. Leave some space here, okay? So we're going to add 1 to this. Well, 1 in halves is 2/2. So we're going to add 2/2 to this. So leave a little space. We're going to add u to the 5/2. Now, we would normally divide by that new power, divide by 5/2. But a better way is to multiply by the reciprocal. So instead of dividing by 5/2, multiply by 2/5. So 2/5, and then plus. And this u to the 1/2, we're going to add 1 to the exponent and divide by that new power. So we're going to add 2/2 to this. So that would make, and leave a little bit of space here. So that'd be u to the 3/2. Divide by 3/2, but a better way is to multiply by 2/3. Okay, and we've now integrated, right? So we actually have a plus c now because we have the constant. This is the antiderivative of this. All right, so the next thing we can do is distribute this 1/4. So 1/4 times 2/5 would be 2/20. I'm going to slide my paper up a little bit. 2/20 u to the 5/2 plus, this would be 2/12 u to the 3/2. And then we have 1/4 times c. Well, that would just still be a constant, so we can just write plus c here. Because it's still a constant, just a different constant than this one up here, but it's still a constant. So the next thing we can do is let's reduce these and replace our u's. So 2/10, or not 2/10, 2/20 becomes 1/10. This u was 2x minus 1 from up here, so we're going to replace it back. So 2x minus 1 to the 5/2, and then plus, and then 2/12 becomes 1/6. And replace this u with 2x minus 1 raised to the 3/2 power plus c. And that's the So our next problem is the integral of x plus 1 times the square root of 2 minus x dx. And what is this equal to? Okay, so if you look at this, you're looking at the inside. We always want to try to look, and remember when we do this, it came from the chain rule. So we want to look for a function within another function. So you see this square root function, and inside that we have this 2 minus x. All right, so, and it's a product. So how can we take care of this x plus 1? All right, so a lot of times what happens is when you have square roots or cube roots or any other kind of root, you're going to let the inside of that be your u, and you're going to be able to pick up this stuff by solving for x and replacing this x with u. Because then what's going to happen is you're going to be able to take this and distribute it out. So I'll show you that in just a minute, okay? We did it in the earlier problem too. So let's let u be this inside part. So let's let u be 2 minus x. And then du would be the derivative of 2, which would be 0. And then the derivative of negative x, okay, so that'd be negative 1 dx. And see how in this instance, we don't pick up this part of it, right? Like we did in the last problem. So what else could you do? Well, what you could do is take this u right here, which is 2 minus x, and solve it for x. All right, so we're going to take this and we're going to solve it for x. What I'm going to do is I'm going to move my x over and then move my u over. So this becomes u plus x is equal to 2, which means x would equal 2 minus u. Okay, so back up here. Now we're going to replace everything. So we have the integral of x plus 1, but our x is going to become this 2 minus u. So 2 minus u plus the 1, and then times the square root of x. Now, our dx, we need a negative 1 with it. Well, how we can fix that is to multiply by another negative 1. So this is going to be a negative 1 times negative 1 dx, because negative 1 times negative 1 is positive 1. So that's how we're going to get that negative 1 there. So this 2 minus u, let's replace it. Let's show everything that was over here. This was my x, and I made a mistake. That should not be x right there. Excuse me. This right here should be a u. So let's fix that. So square root of u. Okay? And then this right here is my du right there. Okay, so let's go through. This is equivalent to the integral of 2 minus u plus 1. This becomes 3 minus u. And then times u, and I'm going to rewrite this with the power. So instead of square root of u, I'm going to rewrite it as u to the 1/2. And then it's going to be a negative 1, this negative 1. So times a negative 1. And then this part right here becomes my du. Now this negative 1 is a constant, so I can pull it out of the integral. So this is negative 1 times the integral. And this right here, I can distribute it out, okay? And so this becomes 3 times u to the 1/2. That's what, when we do this substitution for x and we replace x in terms of u, this is going to be something that we're going to be able to multiply out a lot of times. Not every time, but a lot of times. So this becomes 3u to the 1/2 minus, okay, so this is u to the first power, or u to the 2/2, and so we're going to need to add our exponents, so this becomes minus u to the 3/2. This negative 1 got pulled out, and then my du, and now we can pretty easily integrate this, okay? So this is equivalent to negative 1, and then times, this integral is going to be 3, so let's write the 3, and then times, leave a little bit of space. When you have fractional exponents, I would leave a little bit of space. So times u to the, and I'm going to add 2/2. Add 1, I'm adding 1 to this, so that becomes u to the 3/2. Divide by 3/2, but a better way is to multiply by 2/3. And then minus, and I'm going to add 1 to this, so that's going to become 5/2. So u to, I'm leaving a little space there, u to the 5/2. Divide by 5/2, right? But a better way is to multiply by 2/5. And then plus your c. Okay, let's clean this up a little bit. So here my 3's will cancel. I'm going to be left with negative 2u to the 3/2 power. I'm going to distribute this negative, so it's going to become plus 2/5 u to the 5/2 power. In essence, this is going to become minus c, but minus c is still just a constant. So I'm just going to continue to write plus c here. And then what I want to do next is replace what u actually is. And u was up here, 2 minus x. So this, the final answer is going to be negative 2 times 2 minus x raised to the 3/2 power plus 2/5 times 2 minus x raised to the 5/2 power plus your constant c. And that's how. All right, before we start this next problem, I want to talk about what to choose for u. And you're gonna make mistakes. You're gonna choose the wrong thing for u, and then you try to work it out, and it doesn't work out. It doesn't make the problem easier. So those are learning opportunities. Don't worry about choosing the wrong u. Just ask yourself, if it's not making the problem easier, okay, what else could I have chosen for you to maybe make this easier? And the more mistakes you make, the better you get at choosing your u. Like, you're seeing me right now just being able to pick the u out really quick, but it's because I have all this experience and I've done this so many times. All right, that's all you're seeing, is just somebody I've picked the wrong u a lot of times. All right, so if you look at this next problem, okay, we're going to integrate 2x plus 1 over the square root of x plus 4. All right, what do you pick u to be? Do you pick u to be the whole denominator? Do you pick it to be under the square root? Do you pick the numerator? What do you pick for u? Well, you just got to try something. I'm going to try letting this be x plus 4. And here's my thoughts behind it, okay? If I can let u be x plus 4, let's go ahead and write that. U is equal to x plus 4. I'm kind of thinking ahead, all right? So this x plus 4, this whole thing right here would become u. That'd be the square root of u. That would be u to the 1/2 power, okay? And then, okay, when we take the derivative of this, we're not going to pick anything up other than our dx. So we're not going to pick up this stuff, but I'll be able to solve this for x and replace this x with what it's equivalent to. And when we do this, we'd be able to divide this by u to 1/2, because this becomes just a single term, and we'll be able to divide that. So that's kind of the thought process that's going through my head right now, okay? So if u is x plus 4, what is du? Well, du is the derivative of x plus 4, so that would just be dx. So du only picks up this dx, that's it. Okay, so how do I pick up this 2x plus 1? Well, if you move the 4 over, right, u minus 4 becomes my x. So this x right here can be replaced with u minus 4. Okay, so this is the integral of 2 times, but instead of x, it's going to be u minus 4 plus the 1 over the square root of u, and then this dx becomes my du. Okay, so now we're going to clean this up a little bit. Okay, so the numerator, the top, becomes 2u minus 8 plus the 1 over the square root of u. We can rewrite as u to the 1/2 power, and this is still du. Cleaning this up even more, this would be 2u minus, the numerator becomes 2u minus 7, so equals integral 2u minus 7 over u to the 1/2 power, and then du. Okay, so this is back to this idea of, okay, where did this come from? Well, this came from two fractions that you were subtracting with a common denominator of u to the 1/2. So this is the integral of 2u over u to the 1/2 minus 7 over u to the 1/2, and then du. Okay, the exponent on this u right here is a 1, or 2/2 power. Okay, so I'm going to write that in red. So this is a 1 right here, which is 2/2 power. 2/2. Okay, so what's the exponent rule for this? Well, you're going to subtract the exponent. So it's going to be this exponent minus this exponent. So this becomes the integral of 2u to the 2/2 minus 1/2, which becomes 1/2. And this is really minus, this next one is minus 7 times 1 over u to the 1/2. Well, 1 over u to the 1/2 can be rewritten as u to the negative 1/2. So this becomes minus 7 u to the negative 1/2 power and du. And now it's fairly simple problem to integrate. So then this is going to be equivalent to the, whoops, I'm going to start taking the antiderivative. We don't need the integral symbol. Okay, so this is 2 times, okay, and again, fractional exponents, I would leave a little bit of space. 2 times u to the, we're going to need to add 1 to this exponent, so that becomes u to the 3/2. Divide by that new power of 3/2, but an easier way is to multiply by 2/3. And then minus the 7, leave a little bit of space. U to the, we're going to add 1, so we're going to be adding 2/2 to this. So that becomes 1/2. Divide by that new power of 1/2, but an easier way is to multiply by 2. So this answer becomes 4/3 u to the 3/2 power minus 14 u to the 1/2 power. And you know what I forgot? I forgot the plus c. So let's put a plus c right here. Because as soon as you take the antiderivative, you're always going to have that constant. And then plus c here also. Okay? And so then this u right here, we're going to take back and replace with what it's equivalent to, which is up here, x plus 4. So this is 4/3 times x plus 4 to the 3/2 power minus 14 times x plus 4 to the 1/2 power plus c. You could rewrite this with roots and powers. Like this would be the square root of x plus 4. That would be fine. There would be nothing wrong with that. This could be written as the square root of x plus 4 and then cubed. You could write it that way too. But you don't have to. You could just leave it with fractional exponents. That's perfectly fine. Okay. So the next problem is, how do you integrate tan x? Okay, because you can't do it from the idea of, okay, so what do I take the derivative of to get tan x? And then go in reverse would give me the integral of tan x. And there's nothing out there that you could do that with, okay? So we got to think of another way. We got to be kind of creative and think of another way. How could we rewrite tan x? Okay, so let's rewrite. And if you recall, okay, that a trig identity, tan x is equivalent to sine x over cosine x. So we're going to rewrite this as the integral of sine x over cosine of x and then dx. Okay, so how is that useful? Like, how can we use that? Okay, so you got to think of, okay, now I'm dealing with sines and cosines. And the derivative of sine is a cosine, and the derivative of cosine is a sine. So we're going to pick up sine or cosine by letting u be the other one, okay? So let's let u be this cosine of x, okay? And see what happens. So u is equivalent, let's let u be cosine of x, okay? So what's the derivative of cosine x? And the derivative of cosine x is negative sine x. And then dx. So this sine x times this dx makes up my du. I'm missing something though, and that's this negative 1. But I can always fix that because negative 1 is just a constant. All right, so this is going to be rewritten as the integral of, okay, so instead of writing it this way, this is this equivalent to 1 over cosine x times sine x. So I'm going to rewrite it as 1 over cosine x times sine of x, but then I have this dx too, right? So I'm going to need this, and I'm going to need a negative 1. So I'm going to put a negative 1 here. Actually, I'm going to put it right here. So negative 1 times a negative 1, and then my dx. Because negative 1 times negative 1 is positive 1. And if I multiply this out, this would be sine x over cosine x dx. And it's equivalent to this. All right? But this sine x along with one of these negative ones and the dx, these three pieces make up my du. So this is going to be rewritten as, and then this negative one right here, I'm going to pull out in front. So it's going to be a negative 1, the integral of, and then 1 over cosine x. Well, cosine x is going to be u, so this is going to be 1 over u. And you see how that's going to be that's an integral that we know how to find. And then these three pieces make up my du, and this makes an integral that's we should know already, okay? So this is negative 1, and the integral of 1 over u du is the natural log of the absolute value of u, and because we've taken the antiderivative, this is going to be plus c. And so the only thing left to do is to switch this and let your u be the cosine x. So this is negative the natural log of the absolute value of cosine of x plus c. And that is the antiderivative of tan x. All right? Now, I want to talk about something else. What if we were trying to integrate cotangent x? So let's write cotangent x dx. What do you guys think we would need to do for this one? Very similar to the one we just did, right? And what we would want to do is rewrite this as cotangent x is cosine x over sine x dx. And what do you think you'd want your u to be? And you'd want your u to be sine x. And then du would be cosine x dx. And for this one, we could just go right to the cosine x and dx makes up your du. Okay? I'm not going to finish this one, okay? But that's it for integration by substitution day 2. Okay, guys, here's the assignment sheet. Let's just fill out the date. Okay, so this is the 20th that we assigned this, anti-differentiation by substitution day 2. It's really integration by substitution, okay? And you guys just have a wonderful day, and I'll make this homework due on Tuesday, and then you'll see this in Google Classroom. All right, guys, take care. Bye.